Greetings from the mothership. This is the Calculus Connection, coming to you live in your eardrums. Today's the chain rule. Chain, chain, chain. Use this rule when you have a composite function. What's a composite function? It's a function inside a function, right? Now, get in touch with your inner functions. There is two ways of showing this rule. This notation actually isn't as useful right now. It gets more useful later on when we do something called integrating, which is sort of like an inverse operation of differentiating. I find, what the?
That was magic.
I'll say. Okay? Anyways, this notation I find more useful to understand this rule. They're both necessary though. This very first time, I'm going to do it the other notation, the du dx stuff. So, what we have to do is, remember at the start of the year I was having you guys rip this function apart. What's the inside function? What's the outside function? This is why. And now, I hope this is obvious. What's the inner function idea? X squared plus 1. So we're going to let u equal, so you start off with a statement, let u equal, we're going to go with x squared plus 1. Okay? So, then, if we do that, I'm going to use a different color. Then we have y equals 5. Now, instead of that something cubed, we got u cubed. You see this is the same function?
Yeah.
All I've done is replaced the u for that expression. It really doesn't matter what it was. X squared plus 1. Could have had something with a square root in it, whatever. Now, let's examine both ways. Now, if I look at this, we'll look at this way. What does this really mean? dy by du. If this is y, what's dy by du? You guys follow me? The derivative of this expression. Usually we say dy by dx. Why dx? Because x is usually the variable inside the equation. Does that make sense?
Yeah.
Okay. I never really brought that to your attention too much. We'd say the derivative of the equation y with respect to the letter x, taking care of business with x. This means dy by du, the derivative of that simplified equation with the letter u in it. And it should be simpler than what you started with, simpler than this, okay? Now, so the derivative of the y equation, the original y expression with the x's in it, that's what we're talking about here, right? Is the derivative of this u equation here. So I'm going to call that, I'll say dy by dx is equal to, well, dy by du, which is, what's the derivative here? The dy by du part. 15u squared, right? So I got my color. Okay. We took the derivative basically of the outside function. Do you guys know what I'm talking about when we're, remember how we called this u? So the outside function is 5 something cubed, right? 5u cubed. Now I gotta take care of business and do the derivative of basically what I declared to be my u, my inner function, right? X squared plus 1's derivative, du, the equation u, with respect to the letter x. So it's 2x, okay? So I'm going to use green for that. So I'm going to put brackets around that first chunk, and then 2x plus 0, so 2x. Okay. Now, hold
Wait, are you dividing
No, this is the symbol for a derivative. It's not division though,
here?
right? Is
Oh, I
that,
thought it was like dy, I don't know.
so like this symbol, right? It's not really a fraction, it's just a symbol. Just like f prime of x though, really, right? That's what that means, f prime of, okay, derivative of. Now, one last problem though. This answer has a u in it and the original expression didn't. So we got a backward substitute, right? Pop in what u is equal to and we're set.
U equals X.
So, this is equal to. Should we do two things at once? Sure, why not? I think we can manage this. 2 times 15 will take care of that, right? 30. Which pen? I'm just deciding. I'm just going to go with black here. 30 x. And then the u squared part, I'm going to put. And a little square on the outside of that. So this part here is the u squared. Did I do too much at once? Did you guys follow me on that? You're just good at watching math, or did you go with me? Now, that's thinking about it in terms of the dy kind of notation, right? You guys are going to be good enough, though, then let's just see if I was to use the other notation to think about this. Because the whole point is to save a little bit of time. You can always set this aside and say let u equal. But can you just keep this in your mind as that's the inner function? This part? And not actually explicitly write it out? So here's what I'm saying. Same question versus this method. I'm going to think of it in terms of like this. So what's my f expression? What's my outer function? That's 5 something cubed. What's my g of x, my inside function? That's x squared plus 1. You're going to get the same result, and it really is the same thing. But I'm not going to substitute and say u equals, because I'm going to keep track of that in my mind. If you have trouble keeping track of it, use the left method. Otherwise, try this. So, what I am saying is the outer function's derivative. So if y equals, I'm going to choose this pen. I'll call this y prime. It's the same as dy by dx. Is equal to. Now I'm calling, just so you know what I'm calling each thing, I'm going to just write it out right here. Actually, just so it's not ambiguous. Y equals 5. This is my outer function, right? My inner function is x squared plus 1. Okay. Same as before. But I'm trying to apply it with this rule here. This rule is if I'm taking the derivative of that expression, I do the derivative of the outside expression, f prime, but I leave the inside untouched. Does that make sense?
Yeah.
Times the derivative of the inside expression. It is the same thing as the other rule. Let's just see how that works though. What's the derivative of the red, the outside function? Because it doesn't matter that I have x squared plus 1. I'm just thinking, what's the derivative of 5 something cubed? And you say 15 something squared, right? Just so happens that this is it. So I'm going to go with 15 something squared. I do not touch the g of x, right? It's still x squared plus 1. Now, times g prime of x, the derivative of the inside, which is 2x, correct? You see you get the same result as that. One less step, though, in a sense. Because now you would still take 2 times 15 is 30. I'd scooch the x up front too. You got the same thing, right? Two ways of thinking about the same problem. That's all I'm trying to say. So, in this particular case, I'll color code things again. What's my outer function? 6 something square root, right? Yeah. Think of it that way. No. You don't need to use different pencils, but my inner function is the 4x minus 3, right? Composition, composite functions. Now, when I do this, dy by dx doesn't mean which rule or which form of the rule you're using. It's just notation. The derivative of that expression is, now, looking at this means derivative of the outside function. So I'm going to do the derivative of the outside function. What is it? I'm not actually explicitly going to say u equals 4x minus 3. I'm going to just do it. 3, 1/2 of 6, something to the negative half, yeah. So 3, something to the negative 1/2. Do not touch the inside, leave it alone, right? Times the derivative of the inner function. Then you can simplify it, it becomes 12 in front, right? That's all. But if I ask you strictly to just show the first step, that is it. If you were trying to match that to an answer in an answer book or something like this, you'd most likely have 12. And instead of negative 1/2, what does the negative mean? Where will it appear? Square root downstairs. Downtown Brown, big shout out to Downtown Brown. We're missing you, man. If you're watching this on the internet. Okay. That's what that means. But if I'm saying on the assignment, those first few questions, I say show only the first step, don't go further. Because if you show me a mistake, you will face the punishment, which is quite severe. 50 lashes. Oh, I don't teach in that school like that. Okay. Now, sometimes you've got some options. On your assignment, I'm asking you to do the questions as given, as is. So if this was on your assignment, I'm asking you to use the quotient rule, right? And that's not too hard. But can you think of a way I could rewrite this to not use the quotient rule? Yep.
Bring it upstairs.
Bring her upstairs. He knows what I'm talking about because he's done this before. What would that turn into? What Hashim was saying. How could I make that a function where I could now use this chain rule instead of the quotient rule? Don't be afraid of the quotient rule. I'm just showing you how to manipulate something. Uh-oh. How do we flip things downstairs? Flip the negative sign to positive sign for the exponent, right? It works the other way around too.
You have 1 over x squared for q times.
Yep. This becomes negative 3. Now just think about this for a second. Do you agree that this is the same expression? Okay. So on the assignment, I'm saying use it as is, other than changing roots to fraction exponents, okay? You'd use the quotient rule if I gave you that form. Same problem, but I'm going to ask you to use the chain rule. Okay. So, let's go with this. So f prime of x. Hey, on your assignment, I'm going to be a real jerk if you aren't putting down, if you just put down equals and start doing your derivative, nothing. Well, not nothing, but I'll take off more. F prime of x. Now I'm doing the derivative. Okay? So don't just put equals. Write down f prime of x, y prime, dy by dx, something to notate that. Derivative of the outside. Hey, this isn't bad at all. Negative 3, something to the, subtract 1, so minus 4. Leave the inside alone. Derivative of the outside, leave the inside alone, times the derivative of the inside. So that's first step, done. Bingo, bango. And then after that, if I want to clear up with all negatives and stuff like that, well, I got 2 times 3, so minus 6, x on top. If flip the 4 down to the bottom. We are done, right? By the way, if you were to use the quotient rule with this one, you've got the quotient rule, but inside that you've got to use the chain rule inside it too. We'll talk about that later. Then something a little more abstract. Am I good? How about this? I've got a chart of values. F, G, F prime, G prime. So I don't know what the function is, but I know the function at selected values, right? This is sort of like that question the other day, I think 2 days ago, where you're not told what the function is, but play around with it a bit. So if the function means composite notation, if big F, the function, is equal to, I'm going to use outer function, inner function, f of g of x, that's that notation. It means f is the outer function. Oh, g of x. Find f prime of 4. So I'm doing it. Well, first we got to find what f prime of x is, and that, like, as a thing. We just apply the rule to this, basically. It's no different than the other one. So the derivative of the expression is, what's the derivative of the outer function called? I don't know, it's not like the other ones, but we're going to just say it's derivative of the f function. I'm going to say it's f prime of whatever. Don't change the insides. Times do the derivative of the inner function, the g prime of x, yeah, the derivative of the inner function, whatever that is. Okay. We were told to evaluate 4. Derivative at the value of 4. So, anywhere I see an x now, I'm going to replace it with 4. So f prime of g of 4 times g. Oh, got mixed up on my colors. Not that that matters too much, but be consistent. I'm ready to use the chart. So basically, this is rewriting the rule as given on the first page, right? Derivative of the outside function, leave the inside alone, times the derivative of the inside. You'll be given the formulas on this test, but just should get so familiar to you next year in university if you take this stuff, you'll know it. How do you evaluate this function, you might be wondering again. I do the inside first, right? So what's g of 4? G4 is 3. Okay. So this turns into f prime of 3. Right? I looked that up. Why am I getting confused? Now g prime of 4 is 2. So I'll replace that with 2. Times 2. Now, I want to make it clear that you can't multiply 2 and 3, right? That's still inside the function, the 3, right? So now I look up what's f prime of 3. And it's 8. So this is 8 times 2. 16 overall. You guys follow that? I think so. I think you do. If g prime of f of x and, well, g prime of 5, I'll let you guys try those ones. Okay, I'm going to stop the recording.